Hello everyone, I'm going to talk about the consistent hashing. So, yeah. Okay, so it's a consistent hashing. So what is consistent hashing? Consistent hashing actually is an algorithm that revolutionize distributed system by solving the simple problems. How to distribute the data across the different servers while minimize the distribute while the numbers of servers change. So while the implemented details can get complex, the core concept is beautiful, very simple. Just arrange everything in a circle and work clockwise. This elegant solution is now built in many of the distributed systems we use daily, from the DynamicDB to Kestrel. Okay, so this is what it is. It's treated as an algorithm, treated as the strategy to solve some problem. So why we need it? So we can come here for start from the example here. So for example, this is the very basic like ticket master, right? So clients can call the service and from the database to get something. So this is very basic one. But with the service, the application is become popular, so we need a lot of database. So it will become the microservice architecture. So it will have 1, 2, 3. So when we encounter this one, how could we store the thing in the servers? So we can use the hash, right? Based on the clients sending the new event, as kind of like sending the new requires, we can hash it, model it. For example, we hash this 1, 2, 3, 4, right? Hashing this one. Okay, so what is 1, 2, 3, 4? Whatever. This is numbers. Then store this is event on the database. This is kind of like a hash. This is kind of hash numbers, right? Hash numbers depends on this one modified 3. It's what decided to the database 2. So this is how the servers separate different events, how they are separate to the different database. And then at this time, we will encounter some problems here. For example, if we want to add one of database, right? So which means current event need to change. We now 4, so we store the event on the database 3. Now we need to move the original is in the database 2, right? So we need to move the database from the database 2 to the database 3. So all the data from database is potential redistributed. So you're feeling the problem here. So you have to make some very old information to distribute again. So during this, maybe encounter something. So not happy to do that. Or if you, for example, like this one database, we would ever encounter some terrible problems. We don't want it. And then all the data from this is also, right? So not just the, even we want to remove this data 3, this one is also be impacted. This one also be impacted. That's why we need to model 2. And the hash is 1, 2, 3 and 6, 7, 2, 1, right? So we modify 2, so store the event on the database 1. So original this event will move to the database 1 again. So to avoid these problems, we have to find a good way to handle those problems. So that is what is the consistent hashing is doing here. Because consistent hashing is the idea about clockwise, right? So for example, when a database does event 2, right? Hash 2 is equal to 60. Then we have to find on the 6. Okay, 6 based on the clockwise, we will store the database 2 inside. So this is how the data stored in the, we use this way to choose the database. And then how could we add it? If we want to add a new database, it's very easy. So we just for example, we want to add the database 5s at the 90 here. So we didn't change all the data. We just changed like 75 to 90, and those of event will be redirected into the database files. So we just only change small parts of the data. So how could we remove someone, right? So as, for example, the database 3, right? So database 3 is when this one maybe encounter some terrible problem, we want to remove it. So from the data from here, right, you can see 25, 25, 50, it's just a move to the database 4. So it will not impact the whole database. But also, it will also trigger another problems like if this database is very large and the database 4, we don't have too much space, how could we do that, right? And then it will jump out a new solution from here. It's use the virtual node to redirect the database. You can see here, database 1, it is not virtual, right? So this is DB2, is virtual database. It's kind of like how do you think about that? It's when the 5 here, right? It's kind of like market to this position is market to the database 2 here. And for here is market database for the database 3. And the database 4 is market for the position. So if you can see, you can see a table here. And this one, 5, is belong to the database 2. You have to store that. So use this way, we can separate some part of database, not put all the data into the one single database. We can separate them, and this is a good strategy to make sure the average, right? Make sure the database it has the average data. So this is how it works. So for example, like data 3 is just gone, right? So original 45 and 50, this data will move to the database 4. And for here, for this part about this one, 65 is moved to the database 4M. Yeah. And for here, why always database 4? Okay, should not database 4. I think it should be this. I think we need to change here. Not a database, always database 4. It's kind of like you have to random make market. And then maybe this one is the div 3. It should be the 1, whatever, 1. And this one should be the, right, this should be the 2. And this one should be not 3 anymore. It's like 2, like 1. And for here is you cannot fix 1. So it's kind of like if this one is broken, so set the average, separate the whole database information separate into the different database. So this is a virtual node working here. So it's kind of like an idea about this. Yeah, thank you.